Hello everyone, welcome for this lecture. Today we are going to discuss on a two-way control of lamp and a three-way control of lamp and a comparison of fuse and MCBs. So let's see first one, two-way control of lamp. As we all know that this is used in staircase wiring commonly, so we are calling it as staircase wiring as well. Okay, so we are using it as frequently in a staircases, two-way as well as three-way also we use in a staircases. Okay, so it consists of two-way switches. Okay, and it is bit different from the normal switches which we have seen by a single way control. Okay, this will be a slight change in the construction. We will see how it will be look inside and all, and how it operates, and I'll make you a small animated video on this one. Okay, so let's see how it works and all. Okay, observe, this is the phase. Okay, this is the phase. Remember one thing, with a phase only everything is going to change, like whatever the connection you are making, that is going to change with respect to your phase. Okay, neutral has to be connected to directly to lamp. Okay, this is a truth table. We'll see how it is. So observe your you have given a single phase 230 volt 50 hertz supply, neutral and a phase. With a phase connection there are two switches, switch 1 and switch 2. Observe, switch 1 is called as A switch, switch 2 called as B switch. Okay, and this A position, okay, switch 1's position is now kept open. Okay, so now yet we have not connected it all. Right, there are two switches. How it will be connected? Observe this 1 1 and 2 2. Okay, this can be connected in parallel way like this, or else you can cross it also. So okay, based on this it will be parallel connection, it will be cross connection. So hope you would have observed at your house, like while taking stairs up, or at your bedrooms, like anywhere you would have used two-way control of switches. Observe switch conditions, like both are at a downward direction, then sometimes when both the switches are at a downward direction, means light will be on, means lamp will be on. Okay, so that is due to the parallel connection. Okay, suppose if one switch position is upward and another switch position is downward, during this case also sometime our switch will, means a lamp will be on. That is due to cross connection. Okay, we'll study both the connections, but in the exam anyone you can explain. Okay, anyone among this you can explain. Okay, I prefer you to go for this one since it is easy for us. Okay, but I'll explain both of them. Okay, let's see first this connection, parallel connection. As we have said, A switch and B switch, switching position of A and switching position of B is kept open. Okay, let's take this one. All right, let's do a small exercise here. So it is neutral and a phase lamp when it is going to operate. Let's take A position of the switch. Okay, let's take A position of the switch is at 1. Okay, 1 of your switch 1. Okay, of your switch 1's, it is at position 1. Okay, now A position is 1, and what about your B position? Let's take it is also at 1. Okay, then B position is also 1. Then what about, is that a circuit closed? Remember, circuit should be closed, then only lamp is going to glow. Okay, if not then no, right? So then observe, is this your circuit is closed? Yes, this is closed, right, along with lamp, then your lamp is going to glow. Okay, so then you can say in a lamp you can write here it as on. Okay, yes, now let's see second case, when lamp is at second first switch. Okay, first switch is at 2. Okay, second switch is at 1. Okay, observe, is this your circuit closed? See, now here it came and it is open, and from here it's also open, and it is like this. There is no connection between these two, therefore switch will not be operating. Meaning of this one is, when switch A is at 2, when switch B is at 1, your lamp will be off condition. Okay, so then what we have to do is, let's take another one. Okay, So this we have seen, and now let's take this one. Okay, when switch position 2 and position 2, means A switch is also at position 2, B switch is also at a position 2. This is a closed circuit, so then your lamp is on. Suppose if a switch is 2 position and a 1 position off, as well as switch 1 condition and it is at a 2 condition, that is switch 1 and switch 2 is condition, it is off. Observe here, this is the truth table. If both at 1 position, switch A and switch B, okay, then it will be on, switch will be on. Suppose both the switch at 1 and 2, see switch A is 1, switch B is a 2, off condition. Okay, and the next switch A is at 2, switch B is at 1, then also it is off. Suppose your switch is at 2 2, then switch means your lamp is going to on, right? This is your truth table, and whatever I have explained, when the switch is at position this one, switch is B, it is at position this all things you supposed to write in the theory. Okay, suppose if this is in a cross connection, okay, suppose if it is a cross connection, let's see, it's a truth table. If a switch and a B switch, okay, it is 1, it is also 1, 2, and it is also 2. Observe your switch A is at 1 and B is also at 1. Okay, B is also at 1. Observe this circuit, is that closed? It is like this and it is like this. So this is not connected at all, right? So therefore your lamp will be off position. Okay, that is switch A. I'll take this one. Now switch is at 1, here this is also switch it as 1 at 1, so now this will be off position. Okay, whereas here it is on position. Okay, this is due to connection. Okay, this is due to connection. And next let's take a second position, that 1 and 2, that is first position, so first switch is at 1, second switch is at 2. Okay, 1 and 2. Observe, is this a circuit closed? Yes, circuit is closed in crossway, so now lamp will be on position. Okay, I hope you have got how to do this, right? Let's take a third one, 2 1, switch 1 ka second position and the switch 1 ka first position. Okay, now also it is closed, right? So therefore it is 2 and 1, lamp is on. Okay, and last we'll see 2 2. If this switch is at 2 and if this switch is at 2, see, observe, this is open and this is also open, so lamp will be off position. Okay, I hope you have understood this. Okay, so where and all we are going to use this two-way control of lamp, we are going to use in staircases. Okay, and bedrooms, means like, domestic purpose, like bedrooms, most probably we prefer there only, and the staircases most of the time. Okay, let's see a three-way control of lamp. Remember, three-way control of lamp can be used for very big halls. Okay, and godawans, like godawans, as well as in theaters, as well as this one mostly used in staircases also, like where you have a more than 2 floors. Okay, there you can use this more than one floor also, you can use this three-way control of lamp. Okay, so let's see how it operates. Okay, remember, it has as we said, this has a 3 switches, three-way control of switch. Okay, it is entirely different from your single way, two-way switches. Okay, let's take, this is a switch 1, this is a switch 2. Okay, this one is a switch C, which is called as intermediate switch. Okay, intermediate switch. Let's see, this position is also 1 1 position. Okay, we can connect it to 1 1, you can connect it to, like, parallel connection as well as cross connection. Make use of this and your three-way control of lamp can be operated. Okay, I hope it is clear about this construction. Let's see its truth table, how it is going to operate. Okay, I'll explain along with this truth table. Okay, we'll take a different color. Yes, switch, this one will prove. Okay, means how not prove, let's see how, whether only one condition is circuit should be closed. Okay, then only our lamp is going to on, right? So let's see how it will be. Switch A position is 1. Okay, this position is at 1. Next, intermediate switch C position is 1 2 and 3 4, means 1 2 and 3 4. Okay, and then switch B should be at 1. Okay, now let's see, is this closed or not? Yes, the supply came. Yes, it is like this, and this is the connection, and this one, yes, so it is a closed one. So therefore your lamp will be glowing. Okay, on position, right? So now let's see the second case. The switch 1 is at first position. Here it is cross connection 1 4 and 3 2. Okay, and switch A is at first position. Okay, observe, is this closed or not? Okay, yes, it has came here, and a cross connection. Yes, this is open circuit, means kept open, right? Here it is closed like this, then there is no close path to flow the current. Therefore switch means lamp will be off position. Okay, and next we'll see it's next one, that is let it be for a first condition, means switch 1 is at first position, and this is at 1 4 and 3 2. Okay, cross connection, right? And then this position at 2. Okay, let's see how is this flows. Show closed path. Yes, this is closed, cross, and then again it is closed. So therefore your bulb will be on. Okay, or lamp will be on position. Okay, and next let's see the other one, this one. Okay, now the position of the lamp is 1, same we have kept, and here we have taken 1 2 and 3 4 connection, and switch is at a 2 position. Okay, so now let's see, is this operating or not, means closed path or not? Yes, it is closed, 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 but open. Okay, at the end of this switch it is open, therefore there is no flow of current, and hence your lamp will be off position. Okay, similarly this one, this position is at 2. Okay, and this is at 1 2 and 3 4, and this position is at 1. Tell me whether this lamp is going to operate it or not. Let's see this. Yes, it has came, crossed, and kept open. Okay, therefore switch means lamp will not be operating. Okay, I hope you have got this all. Let's see the last one now. Let's keep the first switch at the second condition, and then there will be 1 2 parallel connection, and then switch is at a second condition. So observe now, is this a closed one? Yes, so parallel connection, is it has closed? Yes, now bulb will be on. Okay, or a switch means lamp will be on position. Okay, I hope you have understood how it has to be. Okay, whatever I have explained, like when the switch A is at this position, switch C is at this position, switch B is at this position, and then what is the condition of a lamp, these things you have to explain, okay, while writing. Right, and again I repeat once, this has to be done, whatever the connections you have made has to be done on the phase, not with respect to the neutral. Okay, and then next we'll see the comparison between the MCB and a fuse. Remember, MCB and a fuse does the same work, like purpose of this is the same, to means protect the domestic appliances. Okay, since we are using and we are studying a domestic wiring and all, so fuse and your MCBs does the same thing. Okay, purpose of this is to protect the devices. Only thing is, what is the difference between these two? Okay, so observe this one, where this has to be, the operation of a fuse is highly dependent on the selection of its proper rating. Okay, on what rating you are using that conducting wire, which one you are using, based on that, and a rated current which is flowing, based on that it has to be chosen. Okay, MCB is instantly disconnected the supply automatically in the event of short circuit or overloaded. Meaning of this one is, I hope you have heard the word tripping. Okay, you would have heard the word tripping, ki any overloaded at your house, means like anywhere, like as I have shown you in a domestic wiring, shown you MCBs of different stages, so you would have observed now. Okay, so this will not be create any risk of a fire and all. Okay, and it prevents the damage of your home appliances. Even it does the same thing, only difference is that when it does, then replacing it, it takes a time. Okay, and it has to be chosen, that wire has to be, means conducting wire, which is going to burn, that has to be chosen according to the rated values. Okay, and here also it is taken, designed rated, but it does the automatically. Okay, so this is the one difference, which operates replacing and all by manually, whereas this one is very easy, and it does the without any risk of a fire and all. It sometimes you hear some voice of this one. Okay, and second one, it has to be, means in a fuse, this has to be replaced by a new wire. Okay, that is a conducting wire once it is blown fuse. It means once it is burnt, you are supposed to replace it, whereas this one cannot be, means not like that. Once it is stripped easily, like a switch, you can operate it again. Okay, so once it is restored, you can bring it back to its original position. Okay, and then it is bit risky while doing in a dark, means like during night and all, when where there is no light. Right, so then third one is, during replacement of the fuse wire, the exact size of fuse wire has to be chosen. Okay, that may not be available at all the time. Okay, and then you're supposed to keep all those materials in handy, like it has to be kept ready. Okay, whereas MCBs are not like so, since it is operating like a switch. Okay, once it is overloaded, it trips, and after that you have to bring it back. The distribution system employing MCB provides satisfactory operation, and it lasts for years. Okay, so whereas fuse is not so. Okay, and then the board employing fuse is not so compact. Okay, so it is not a compact one, whereas MCBs are a very compact one, and usual, and even it looks elegant also, means it looks good on the boards and all, whereas your fuse will not looks good. Okay, so these are the some differences, means comparison between the fuse and MCBs. Okay, and two and three-way control lamp. Okay, thank you.